Good morning, dear students. Now, today we will see here how the detection of sulfur from the organic compound is being done. That means we'll see the test for sulfur. So, when in first step, Prussian blue compound is not obtained, then it is confirmed that sample is not containing nitrogen. Because if Prussian blue color takes place, then only it is a confirmation that nitrogen is present. But in first step, if Prussian blue color is not obtained, so nitrogen is absent, and then we have to take some more lysine extract and we need to carry out the test for the sulfur. The sodium fusion extract, that is a lysine extract, is acidified with the acetic acid and lead acetate is added, which gives black precipitates, right? And this black precipitates is of lead sulfide. That means sulfur when reacts with lead, it gives black precipitates. So if black precipitates is taking place, it means the sulfur is in the compound. And when lead sulfide is obtained, it is insoluble in water. Then it is confirmed that there is the presence of sulfur in a sample. So when sodium fusion extract is taken and it is acidified with this acetic acid, then sulfide ion is separated, and when lead acetate is added, then lead ion is separated. These lead ion positive 2 and sulfide ion negative 2 when combined then gives lead sulfide, that is black precipitates. Now on heating sodium extract, this is the another method. So this is the one method in which we can confirm that there is the presence of sulfur in organic compound or not. And one more method is there on heating sodium extract. So sodium extract is to be heated with what it is heated? It is heated with sodium nitroprusside, Na2, FeCN5NO, the complex inorganic salt, highly hydrated because 2H2O is present. That means water molecule is present in the compound. Compound is not purely dry. It is little wet because of the presence of water molecule. Na2, FeCN6 nitro. So this is sodium nitroprusside. Now, when sodium extract is reacted with this sodium nitroprusside, then there is appearance of violet color because of the pentaferrocyanate. The violet color appears when it reacts with the sulfur, and this gives the idea that there is the presence of sulfur in the organic compound. Sulfide S2 minus when reacts with FeCN5NO2 minus, right? Pentaferrocyanate nitrosyl. When reacts with the sulfide, then this exists as pentacyano-nitrosyl ferrate. What is it? Pentacyano-nitrosyl ferrate, and this is called nitroprusside ion. Negative 2, negative 2. Both negative ion will combine to give negative 4, and it appears in violet color. So when these ferrocyanate group reacts with the sodium of the sodium fusion extract, then 4Na plus when react with this compound, it will give sodium pentacyano-nitrosyl ferrate, and this is also violet color, which gives that there is the presence of sulfur. And this compound, sodium pentacyano-nitrosyl ferrate, is dihydrated. Dihydrated, that means 2 volume of water is added to it, and then that highly dehydrated form of the sodium pentacyano-nitrosulfurate is used as vasodilator. Vaso, that means the blood vessels, and dilator, that means blood vessels are dilated by the use of this compound to reduce the blood pressure. Now, as we are detecting the different groups from the organic compound, and it may happen that sometimes only nitrogen is there, sometimes only sulfur is there, sometimes it may happen that both are there. Then, if both are then what is the steps? If both nitrogen and sulfur are present, then sodium thiocyanate NaSCN is formed, which gives red blood color, bloodish red color. Sodium plus compound containing carbon, because organic compound. So in organic compound, sodium extract is added, and along with that compound, nitrogen and sulfur is present. Then they will recombine as NaSCN, sodium thiocyanate. When this SCN minus thiocyanide, sulfur cyanide, that is thiocyanide, reacts with Fe plus 3 of the ferrous sulfate, because when nitrogen is there, we were adding an FeSO4. So this thiocyanide negative will react with Fe plus 3 cation and gives ferrous cyanate, which is blood red color. So this is giving the idea that there is the presence of sulfur and nitrogen both. If sodium extract is prepared with excess sodium, then thiocyanide will decompose to sulfide and cyanide, giving their usual individual taste. Sometimes it happens that while preparing Lasine's extract, if sodium is added more into the capillary, right? Sodium tastes capillary, then the thiocyanide will decompose and sulfide and cyanide will be separated, giving their usual taste. So sodium thiocyanide, when excess sodium is reacted, it will exist as NaCN and Na2S. So sodium cyanide is separated, sodium sulfide is separated. This sodium cyanide, thiocyanide, so sodium thiocyanide is used as herbicides and fungicides in agrochemical industries. That means those industries which are working for the products for the agriculture based, for that fungicides and herbicides are used by use of this. This sodium thiocyanide is also used in fiber industries as a spinning solvent for polyacryl nitrile. Polyacryl nitrile, right? PAN, which is a flexible plastic, waterproof, and of which the fibers are made, which can prepare the nets, baskets and all with the plastic like fibers. It is also used in construction industries for hardening the cement and concrete mixes. When cement and concrete, that is sand and small pebbles and cement, all are mixed, then in cement, this is one of the material which hardens the material which builds the building and make them strong, right? So this is about the test of sulfur, two taste of sulfur as well as taste of combination of nitrogen and sulfur, and what are the uses of sodium thiocyanide as well as of use of sodium pentacyano-nitrosulfurate 2, right? Now, here is one more Lasine's taste, and it is for halogens, because organic compound is not that it will contain only nitrogen or only sulfur. It will also contain sometimes halogens. So, for halogens, sodium extract is taken and reacted with nitric acid HNO3 and silver nitrate AgNO3. Sodium extract in which HNO3 is added. Now HNO3 is oxidizing agent. So as it is oxidizing agent, it will try to separate the halogen present in the compound in the form of halonitrate. And silver nitrate is added so that silver will get separated and will bind themselves with the halonitrate and give the silver salt of the halogen. Now when these three are added and if white PPTs are obtained, then possibility of chlorine is there. And if this white PPT on adding NH4OH, ammonium hydroxide, is completely soluble, then the possibility is confirmed that the compound contains chlorine. But instead, if yellow PPTs are there, then there is a chance of bromine and iodine. So on confirmation, by adding ammonium hydroxide NH4OH, if yellow PPT is sparingly soluble, that means PPTs are not soluble all together or all PPTs will not get dissolved. Somewhat amount will remain in the solution. Then it is confirmed that the bromine is present. And if PPT at all is not soluble and it remains insoluble, then iodine is confirmed. So then what happens? As I told here, oxidizing agent will try to separate halogen and from silver nitrate, silver will try to react with the separated halogen and give silver halide. So halogen will get separated X minus and silver being metal is positive. So these two will attract each other and give silver halide. Where X is halogen group, it may be chlorine, bromine or iodine. Now, as detection of different groups are done from organic compound, then it is possible that the organic compound may contain only one group or more than one group or even 2 or 3 groups at the same time. So, if nitrogen or sulfur are also present in the organic compound along with the halogen, then the sodium fusion extract is boiled with concentrated HNO3. Why? Because this HNO3 will decompose sodium cyanide NaCN and sodium sulfide NaS. Right? Sodium sulfide Na2S because Na plus S2 minus. Right. And during Leysin's extract, the AgNO3 which is added separates halogens. Then to test for nitrogen and sulfur is carried out to check their presence. So here along with halogen, if nitrogen and sulfur both are present, then the compound is first boiled with HNO3. So the decomposition will take place from that boiling solution and separately cyanide and separately sulfide will be taken out. And still Leysin extract which is there in which AgNO3 is added, so they are completely separated. So nitrogen will get separated over here, sulfur will get separated over here, and along with Ag, that is silver, halogen will be also separated. And then the respective taste of nitrogen, sulfur and halogen is to be carried out. Not has been carried out but is to be carried out for the confirmation. So this was all about the detection of nitrogen, sulfur and halogens. But phosphorus, for detection of phosphorus, directly sodium extract is not taken. Test for phosphorus is not done by the sodium extract. For this, the compound is first heated with oxidizing agent, that is sodium peroxide. Use of sodium is necessary because sodium is a reactive metal. So it can easily react with the negative ions and can proceed for the further reaction. But sodium extract is not used. Instead of that, sodium peroxide is used, Na2O2. So a presence of oxides will provide oxygen and compound will be oxidized. Thus, the phosphorus present in compound is oxidized. So, when oxidation takes place, the phosphorus will unite with it and get oxidized as phosphate. P will attach with O and becomes phosphate. The solution is then boiled with nitric acid HNO3 and then treated with ammonium molybdate, which is yellow color, or PPT indicates presence of phosphorus. So when treating it at HNO3, that means acidified substance, when treated with ammonium molybdate, then the yellow color appears or yellow color PPTs appears, which gives idea that there is definitely the presence of phosphorus. So how this reaction takes place? Organic compound reacts with sodium peroxide Na2O2 gives phosphate. See here, Na3PO4, sodium phosphate. This sodium phosphate when reacts with HNO3 and acidified form gives H3PO4, that is phosphoric acid, and sodium nitrate. Phosphoric acid, we are not bothered for nitrate reaction. When you read further this, it may also give some other product. But here we are testing for the phosphorus. So phosphoric acid is taken. So H3PO4 when react with ammonium molybdate, NH4 twice is ammonium and MO is molybdate. Right? So phosphoric acid when reacts with ammonium molybdate and still the acidified nature is there, that is HNO3 is to be added also, then you will get NH4 thrice PO4 12 MO molybdenum O3 oxygen plus NH4 NO3 and water. What is this? Now see here, phosphate is there, ammonium is there and molybdate. So it is ammonium phosphorus molybdate. Ammonium phosphorus molybdate. Right? It is yellow in color, or you can say it has yellow precipitates, PPTs, which can settle down after some time. The use of ammonium phosphomolybdate is for analysis of phosphates and silicates in the compound and further analysis during the reactions in the industries, which is used as a commercial base, right? So this is how the test for nitrogen, sulfur, halogens and phosphorus are carried out. That means by these qualitative analysis, we will come to know what type of sample your quality of the sample is, what type of quality of the sample is, whether it is nitrogen rich, sulfur rich, halogen rich or phosphorus rich. And then in the next video we will see about the quantitative, that means in how much per amount it is present. By the time, thank you.